Hi guys, in this video we're going to be reviewing the concept of functions and sets, but we're going to be taking it a step further. In the previous video we defined what a set was, which is basically a collection of objects. Then we defined what the real number set was. As it turned out, we had to divide the real number set into specific sets, which were comprising of the integer set, the set of all integers, the set of all rational numbers, the set of all irrational numbers, and in addition to that, the set of all natural numbers, right? There may be other sets, but at this point in time, I'm limiting my scope to these particular sets. Okay, so in this lecture, we're going to be talking about some terms that will be referred to later on in the lecture, okay? So, first of all, this is known as a closed interval, which basically means that we have two values a and b, right? And we have an x-axis over here and a y-axis over here. A and b are basically 2 points on this x-axis. So the point is, a and b represents an interval in which values are going to range from a to b, but the good thing about this closed interval is that it's represented by square brackets and it includes the value a and b. So basically, if I were to give an example over here, the closed interval 1, 2 would comprise of values that start from 1 that go towards, well, they could include values from like 1.1, 1.2 and could go on and on to 2. So basically 2 and 1 are included in this set. So this is a very general example. So I'm basically incrementing every number 1 by 0.1. So what if this were, I wanted to talk about all integers that lie in a particular closed interval. So in the closed interval -4 to 4, I would like you to list all integers. So let's start. So since we know that it's a closed interval, we're going to have to start from -4, right? And then we're going to go to -3 because it's another integer, -2, -1, 0 is another integer, and this would go on and on to 4. Another terminology that we need to talk about right now is an open interval. An open interval is represented by round brackets, and it's basically going to include numbers that lie between a and b. So if x were a number that were belonging to this particular open interval, then x would lie between a and b, but would not include a and b. So let's talk about the closed interval and compare the two. This is the closed interval, but in this case, x would lie between a and b, and x could equal a and x could equal b. That's the difference between these two. We could combine these two and come up with some sort of weird example. For example, I would like you to list all integers in the following interval. Now the interval is going to be slightly tricky. It's going to be something like 4, 11. Listing all integers in this case would not be much of a problem if you think about it. Since it's an open interval from this end, we're not going to be including 4. But the next integer after 4 is 5. And we'd increment that until we get to 11, because since 11 is included, we're gonna have to include 11 because it's closed on one end, right? So that wraps up this section. The next thing that we need to talk about now is the concept of infinity. When we think about infinity, we usually think about a number that's very, very large, right? Actually, our interpretation couldn't be more wrong. Infinity is not a number. Infinity is a notion. It's the notion of a number that's so large that we cannot comprehend it. It does not belong to the real set. So what I'm basically saying is that we talked about real numbers right now, right? So what I'm actually saying over here is that infinity does not belong to the real set. It's a number that's so large, we're unable to comprehend how big it is. Think about a thought experiment for once. Assume there's a number a that's so large it's infinity. If you think about it, you can start adding 1 to it and it would be bigger than the previous number you assumed. So it kind of contradicts the assumption we're making. And it's resulting in a larger number every time we add 1, which means infinity is so large that it cannot be restricted to the real number set. It's important to point out that the laws of real numbers are not applicable for infinity as well. So if you were to add infinity and infinity, that would be undefined. You wouldn't know what that is. And same goes for infinity divided by infinity. We wouldn't know what these things mean because we don't know what infinity is. So do not make the mistake of assuming that we could compute these answers, because the laws that hold for real numbers do not hold for infinity. That's a very important concept. And that's pretty much it for this video.